Okay, so I'm going to talk about SOAP, REST, and WebSockets. And I usually, let's move on a little bit. So and this is a BOF, and BOFs typically what that means, it doesn't really turn out that way, but you can interact a lot. So anytime you want, you got an idea, way to do something, not why you shouldn't do something, feel free to speak up. We'll talk about how to do this. Because I've got a lot of thoughts and ideas, but there's certainly not definitive answers. I think it's way too early for any definitive answers. So this is more like an exploratory session. I do have some slides prepared, but we can talk the whole time, and that would be okay. But just in case, I have a few slides, and they go in about this order. Uh-oh, now what? Well, I had some slides. They're gone. Amazing. Well, maybe we better switch to, oh, and I took that out. Well, we're off to a good start here. Are they really gone? Okay, look, they're there. So how about if I don't, can you read these slides okay? I'm afraid to put it in full screen because who knows what will happen. So let's just go with this. Yeah, okay, so my name's Harold Carr, and I'm the SOAP Web Service Architect at Sun. And generally, I've been giving lots of SOAP talks. And in 2005, I gave one at Java 1, and it was to a room that had actually about twice as many of this, because SOAP was the sexy thing then. And every year I give talks to smaller and smaller audiences. But I got smart this year. I added WebSockets to my title, and look what happened. So, but you're going to hear about SOAP anyway. Here's the disclaimer. Fortunately, I'm not talking about any products at all, just ideas. But in case there's any thought that I'm promising you anything, you're out of luck. No promises. And this talk is copyrighted. You notice I'm not using the slide deck. I didn't have time. Anyway, by the way, there's a whole bunch of other WebSockets presentations. So this is a bunch of them. They're from all over the spectrum. I won't read through these because it would take forever, but there's 2 pages of these. So make sure you go to your schedule and look them up if you're interested in WebSockets. There's a few other SOAP presentations, and one of them I'm giving, this one here, this bottom one, the remoting perspective. Is there a technical guy? Okay, if I hold this, is that the deal? Okay, so anyway, the bottom one I'm actually giving tomorrow night, and it's in a way it's related to this talk because I'm trying to show what's been going on when you try to write programming frameworks that allow other programmers to write programs that talk between computers. And it has a long history from DCE, even before DCE, but I'm starting at DCE and ending up in a WebSocket. So I'm doing that tomorrow evening at 7:30 here if you happen to be in need of some fun. And then there's a whole bunch of REST presentations. And so don't forget to see those. Okay, so some of the questions I was looking at, how to use REST, what do WebSockets have to do with SOAP or with REST? Because SOAP, until REST came along, Corba was the dominant paradigm, then SOAP was, and now REST is. And now WebSockets, everybody keeps talking about it. So, well, where do they fit in? And we're not sure. Actually, I think a lot of people are, but let's pretend like we're not sure, so we can go somewhere. Anyway, so should SOAP and REST use WebSockets as a transport, or should they be used in a complementary way? Which, how many people here know much about WebSockets? No, not too many. Okay. Maybe I should skip these discussion points and talk a little bit of intro to WebSockets first. Yeah, let me come back to this because it won't make a lot of sense unless I do. So let's go. Yeah, let's start here. So this is kind of a history of where WebSockets fits in. So in 1994, that's kind of like the inauguration of the public web. You know, it had been around a long time before that, but that's when everybody else got on. That's when my mom got on. And I was always been wanting her, you know, I was in my EDU account sending her an email, but it never worked. But at that time, HTTP was just strictly request response. So people were just serving up static pages, and then they did CGI and a whole bunch of cool stuff to dynamically generate a static page, a whole page. And that was useful. Certainly, it caused a big information revolution, but it was still pretty clunky compared to like a desktop app. So then Ajax came along in 2005, which is actually quite a long time if you think about it, 11 years in internet time. And Ajax was an attempt to make it a little more dynamic. And there's really nothing magic about Ajax. It's just polling the server and says, do you have an event for me? Instead of the server saying, here's an event, the client's asking, do you have an event? I'll go into a little bit more detail on that. And then in 2006, a whole bunch of techniques that kind of go under the name of Comet, like long polling, HTTP streaming, came along, and they were trying to make this a little bit better. And the trouble is, it still was a fake. So now in 2011, 2010 actually, 2012, I think it's finalized this year. Is it final yet? Anybody know? Not the JSR, but the WebSocket spec with the IETF spec. I can't remember if it's final yet. Anyway, so it does some cool things. So let's go into a little bit more detail. So the HTTP, that is just strictly, you know, it's still setting up a TCP connection, right? But the HTTP protocol says, I'm going to open the connection, I'm going to send one message from the client to the service. The service is going to send the response, and then we're going to cut the connection. And that's it. And that's actually for a reason that lets it scale, because a server doesn't have to have a whole bunch of connections open. And if you've ever implemented a Corbis system, it's a connection-based system, and you have to do connection management, which we'll get into that in a minute about WebSockets. So then with Ajax, all that does is the exact same thing, except for it does it in the background on a thread. So you know, then it's doing this. So you can have this Ajax thing going in the background, periodically polling, and when it gets new information, then you can redraw some of your DOM or the whole page or however you handle it. And that's all Ajax is this request response in the background. So not much really going on there either. But it was actually a big breakthrough in a way. And then this long polling, what it did, the long polling is actually pretty interesting. All it does is, once again, the client makes a request, and then the server just waits. So the connection is hanging out, and the server just waits until it has actually data to send, an event, and then it sends the event. And then after the event comes, the client will then immediately reconnect again after it does something with the event, you know, redraw the screen or whatever. It'll send out another one. So all that's doing is holding that connection open so somebody can send, the service can send the event when it happens. And that's a little bit better because there's no latency at all. But it does mean it's still a fake. There's the last little wrinkle to this is this thing called HTTP streaming. And instead of, like in the long polling one, which I just explained, where the client makes a request, the server doesn't respond until it has an event. The event comes back, the client then handles the event and does another request, and so there's a connection for the server to send a event on. Instead, you keep that connection open, and the service sends back frames of responses, and then, but it doesn't close the connection. That way, it continue to do that. All of these have problems because if you go through, you've got to handle connection timeouts, all sorts of things like that. Or you might have a router that won't send a partial response. And what I mean by a partial response with HTTP streaming is, from HTTP's point of view, it's partial. Even though you put in it some sort of data that your application thinks is a consistent unit, from the HTTP point of view, you need the whole response and then you terminate the connection. This one, you've got an application level unit going across and you're keeping the connection open. Fortunately, most routers don't like to buffer much, so they usually do send the partial stuff through. So that's HTTP streaming. Now we have this thing that's also coming along with WebSockets called server send events, and all that's doing is standardizing Comet. It's really the same thing. It's in a way, but you don't have to do it with somebody's special framework or depending on this. It's a standard way to do Comet, Ajax, long polling, streaming, all that kind of stuff. And it's all wrapped up in a very simple little thing. That's it. So you have this thing called new event source, and here you'd put in the URL to your events, and that's going to open up the connection, and then this thing, on message, whenever a message comes in, the event will come, and then you process it. This is your JavaScript code. So there's more to it than that, but that's the fundamental idea. So, I'm not really talking about server send events today, though. I just wanted to mention it because it's really working in the same territory, and it's from the same angle actually that Comet was, and now WebSockets is a slightly different angle. So I don't trust this thing. Did I skip one? Okay, so what WebSockets, while they're still necessary compared to like server send events or Comet, is increasingly our applications are becoming more collaborative, and Comet type things or server send events, they work great for downstream. What I mean is for the servers to push events to the client, it's pretty fast. I mean, once you have that connection that's hanging out, you send stuff down, it comes immediately. But you can't fake the go-ups, because upstream you can't suddenly start sending new stuff down the output channel from the client-side initial request. So you have to do all sorts of tricks. Mostly it comes down to just sending more requests, and that doesn't scale like a single connection. So that's really where WebSockets comes in, because you want this two-way channel that the client can send stuff to the server anytime it wants, and the service can send stuff back. What happened? Oh, no, it did it again. Don't do that. Oh, I see what's going on. It's somehow switching into that mode. See? Okay, so let's be very careful with this thing. Okay, so this was the thing. Okay. So let's talk about a little bit. Where do I want to? I'm kind of jumping around now because... yeah, I'm going to forget the slides for a minute. So what WebSockets does, WebSockets is absolutely nothing conceptually or technically new. All it is TCP. That's it. The difference is now you have TCP in your applications, which you couldn't do before. That's not completely true. With applets a long time ago, and maybe still you could do it, but no one uses applets. So. And what it means is there's now a standards protocol that the client says, I want to talk WebSockets. But he says that initial message on HTTP. So it's an HTTP message that goes to the service. And the service says, if it can handle it, basically it sends an HTTP upgrade message, and which is how SSL, for instance, is handled. But in this case, now they're adding a standard WebSockets upgrade. So if the service says, oh yeah, I can handle WebSockets, so it'll say, yes, I can, and there's a little bit more magic that goes between them. And what happens is, what they're sending that message on is already a TCP connection. It's a TCP connection running HTTP on top of it. And so suddenly that TCP connection becomes completely open as TCP for the client and the service to send and receive data on the streams in either direction. So that is it. That is the main thing WebSockets is. And that opens up a whole bunch of possibilities. Now, if you think about it, the real motivation, again, is we already had the downstream link from the service taken care of. So for a collaborative app, if anybody changed out there, you can see the stuff fast. But if you change something, they're not going to see it as fast. So this allows that upstream link now to go fast also on the same connection. That's a good thing. But people are going to be tempted to use it to do other protocols. And that's kind of my big question, is that a good idea or not? And I'm not sure. Yeah.
So what changed to make this scalable, and why was this not scalable before?
No, the main problem before is the upstream link from the client to the service. There's no open stream that you can send data on from the client. So you would have to open up another connection and say, here's some more data for you. Whereas the downstream link was always open with HTTP streaming. So with this, you've got that same thing now, both directions on one channel.
Why wasn't this strategy adopted before? The long
Oh, why? Oh, well, that's politics. That's not a joke. Really, that's politics.
I mean, I thought it was more like the server cannot handle, if I had my Twitter page open for 10 minutes and 100,000 people had that page open, Twitter will have 100,000 connections.
Exactly. That's the deal about web. There's nothing's free, right? And that's my main question too, because I came from a Corba background. And Corba was connection-based. And so we had all sorts of connection management strategies to deal with, what's the least recently used or the one that's been idle the longest, all this kind of stuff, so you could kill them off. And because HTTP, the nice thing about it, the service didn't have to do connection management. You got the request, you gave the response, you got rid of the connection, case closed. Now, with WebSockets, all of us poor middleware writers will have to deal with connection management. So they're all going to have to go steal the Corba code. See, it lives on. It lives on. Does that answer your question exactly? I don't think so. One part was the politics. Why so long? Well, really, literally, it's people. When enough people are interested in something, you really need to standardize it. And there have been enough ad hoc attempts that people say, yeah, this works, we should standardize it. So I think that part is. And the other one is scalability is definitely an issue. So where was I? Oh, yeah. So I don't remember. Trouble is, that's when you start jumping your slides around, then you're really in trouble. Okay, actually, well, I gave you a little introduction. Do you understand WebSockets? Yep. Good. So there's not much to them, is there? So you can skip all the other presentations. Okay, so let's go back to my original questions. And that's why I said, should SOAP and REST use WebSockets as a transport? Because all it is this TCP connection that you set up. You told, first the client said, here's an HTTP message. Remember, an HTTP is really flowing over TCP. TCP never went away. And it says, I want to upgrade to a WebSockets. The server says, if the server says I can't handle it, you better have, some Comet code back there to back it up, which is most people are doing still because not everybody can handle WebSockets, and it'll be a while. But that's another issue. So then the server says, no, I can handle WebSockets. So they do a magic, and then suddenly they can just start using the input and output streams of that underlying TCP connection that was always there to begin with. It never, it was just kind of covered up under HTTP. So now we've got that. What do you do with that? Well, once again, the motivating use case is so you can send real-time events back and forth from the client to server, particularly from the service. But if you're doing a collaborative act, like drawing something together, you really want that to work fast. So you need it both directions. But just because you have these, though, that's very tempting. Like, wow, we got these streams. Let's use them. And so let's run SOAP over it. Well, should we? Actually, let's skip ahead to the SOAP slide. Because it turns out doing SOAP on, why would you want to use SOAP? Oh, come on, don't give it away. Why would you want to do SOAP on WebSockets, basically on a TCP connection? There actually is some thoughts, these are just some thoughts. If somebody thinks they're wrong, please tell me, because I certainly haven't done it, just thought about it. But there's this thing called make connection. Make connection is a thing for the SOAP protocol, which allows, if you've got a client behind a firewall and you want some potentially long-running requests, the client can do the request, and then the service can determine, like, I'm going to schedule this to happen tomorrow, and it'll just send a 202 or whatever. I can't remember the number. 202 with some magic code saying, okay, call me back, and I'll have your answer later. So then later, at some polling period, make connection will go back and say, okay, I'm trying again to get the response for that request I sent you a while back. And, it has a magic UUID in there so it can identify it. And their server can say, not yet, I told you tomorrow. And finally, when the client, and it's always polling, can say, okay, now I have it, and he gets the request. And that exists mainly because if firewall, like in the reliable messaging case, if the sender didn't get a message, it's got to tell the other side, like, I didn't get it. With make connection, the client is blasting out of the firewall because the server can't come back in. With WebSockets, you wouldn't need that because you've got that connection already set up. Trouble is, the connection will have to wait as long as the takes for the execution to handle, and that gets back to your question. You've got to do connection management, and if that thing really is meant to take a day, then that connection is probably going to go down. So then you have to devise a whole bunch of connection management strategies. I was talking a minute ago about the server can say, when can I close the connections? But if I close them, but the client says, no, I have something I want work done on that. So the client has to reopen the connection and say, hey, remember me? I was trying to get this done. So not only do you have to do connection management with WebSockets on both sides, but now you've got some state management because both sides have to say, well, what were we doing? Or you have to just throw it away and say start over. But like I said, there's nothing for free. And you could also use, maybe you could use WebSockets instead of WS reliable messaging. Because one of the things reliable messaging will allow you to do is guarantee that you'll process messages in order. And with just regular HTTP and routers, you might send some messages, but they actually might arrive in a different order. But that's because they're all going on different connections. If you've got one connection, it's a TCP connection, by definition, you're going to send them, they're going to come in order. Unless you were doing stuff like running multiple threads. But in web services, if you're using the standard APIs, you can't do that because the standard JAX-WS client-side APIs are not thread safe. So anyway, it's a possibility for reliable messaging. And of course, the kind of easy use case is just multiple messages. If you know you've got something that's going to start up, send a whole bunch of messages, and then be done, then it's actually really good because you don't have to create a new connection for each one of those. Particularly if when you're done, you can actually say, okay, now I'm done. Now I close the connection. Because that way you're decreasing the burden on the connection management side. Because the connection management has to make decisions, and it's not always going to make the right one. When it closes a connection, because it's not being used and it was the one that was idle the longest, that doesn't mean there wasn't work that was going to be done eventually on that connection. So let me, whoops, see, this keeps doing that. Wish I had my, oh, I wanted to show that. Okay, well, I'll get back. See, I'm skipping all over the place, but that's okay. So I'm going to skip to this slide first. So I'm actually, one thing I'll point out about SOAP. SOAP is actually well suited to doing WebSockets, because the SOAP specifications, like WSDL has a place in there that says this is what kind of transport. It doesn't actually assume HTTP transport. It's got a place right in the WSDL which says what kind of transport. It's got a place right in there that says here's the address, and it doesn't assume HTTP style addresses. And so it's actually really well suited to doing WebSockets in terms of the existing specifications, because a lot of people complain about SOAP, and a lot of the complaints are valid, but some of them just are kind of whining because REST is a sexy thing now. Of course, now we know REST isn't sexy anymore either, right? WebSocket is. Sorry, Martin. See, and look, I got 300 people. How many you got? Sorry, this is we work together on SOAP, so he can take it. Anyway, so what was I saying? I got lost again. So SOAP, the actual conceptual infrastructure behind it, the WSDL and everything else, is meant to go on multiple transports because it's an enterprise protocol that gets enterprise work done, like end-to-end security is its really strong point, and strong typing of messages. Okay, but let's switch out of that. That was my plug for SOAP, because I still work for SOAP, so I feel sorry for it because no one cares. It's true. Anyway, so look, here's the WSDL spec, and all of this is standard stuff. Oh, and this is from a Microsoft specification. There's no standard like W3 or Oasis specification for SOAP over WebSockets, and I haven't even really heard any talk about it, but Microsoft has done one, and probably for good reason, some of the ones I was talking about earlier. But here it is, right here. This is where it says SOAP 1.2 binding, transport equals. Before this would say something like HTTP. Instead, they've got their own, Microsoft-specific one that says WebSocket. So that's it. Once you've done that, then your client side says, okay, I need to talk to this guy on WebSockets. And then it says, here is the address, WS, which is what they've chosen to represent it by, which, by the way, WS makes it really hard because I've always used WS for web services, right? And now it's WebSocket, so there's another acronym that's going to get confusing. So anyway, this is the address, but that's it. The rest of the WSDL doesn't change. Everything's exactly the same. So then the handshake message, there's really nothing to show as far as the messages that go over TCP. The message that would go over TCP would be exactly what you see. I actually should have put one in here. They'd be exactly what you'd see in the body of an HTTP message, because you don't need any of the HTTP headers. Everything's self-contained in the SOAP message. So that's what's going to flow across the TCP connection. But to get the handshake going, it did one thing. Somehow Microsoft's, the document says, where it said WS, you magically replace that with HTTP and do an initial GET there. And you notice there it says it's an upgrade to a WebSocket. And they've got some other magic stuff, which some talk to, they'll probably tell you more details about this. That's not the purpose of this talk, to go into the nitty-gritty of WebSockets. And then the content type, and here they're saying it's Microsoft binary. Microsoft's Oh, that's another thing about WebSockets is they can handle binary or text data. And the text is mainly because JavaScript doesn't have byte arrays. So you need to have text to talk to, so you can do JSON basically to JavaScript. And that's it. So that's the upgrade. And then here is the upgrade handshake. Says, okay, I'm switching protocols and we're going. So that's it. So I'm actually saying it's tempting to maybe do WebSockets over HTTP, and I'm probably going to spend a little more time exploring this because if you've got like a whole bunch of applications written on top of SOAP that are commuting internally, I wouldn't use this for interoperability right now, but if you're internally, there might be some benefit. So I'm not completely sure yet. Well, the main benefit is, one, avoiding these two things, make connection and reliable messaging, particularly reliable messaging. I've grown to really be wary of reliable messaging. That spec is one of the seemingly simpler specs in the WS Star catalog, but it turns out it is really insidious. It's got so many corner cases. And if you use it with non-anonymous addressing replies to, so I better give a little detail on that. So in SOAP, if you send a SOAP message, you have these what's called WS addressing headers. And what it says is where to send the response. And if it says anonymous, that means just back on the same channel that you sent on the back channel, on the output stream of the stream that it came in on, and the connection it came in on. But you can also say, no, send it this whole completely different address. Well, that thing alone really causes a lot of problems, because if you have to say you need to retry, I didn't get a message, so you need to retry this one, or I've got a response for you and you never got it and I want to keep sending it to you, it gets to be a real problem. So I'm actually, other than that, I'm not completely sure. You know, if you have a lot of your web services are talking a lot, then saving all that connection setup and tear down might be a win by leaving connection, but with the caveat that you have to do connection management. Or your apps will just say, no, I'm done now, so terminate the connection. So the apps, in a way, would be doing their own connection management. Right, and what happens with this, once you've load balanced the request, you know, when you first set up the TCP connection, it's going to send you to the right place, and that connection is going to flow all the way through, even through the proxy. So the TCP connection. So you're actually making eventually a direct connection to the service itself. Right. So let's go all the way back up to some other slides here. So we're going to, better look and see what time it is. Wow. Okay, let's go here. So, yeah.
What do you consider as a client for this SOAP service?
Say it again?
Like, what do you consider as client, consumer for this service? Is it browser, or it would be arbitrary Java application, or what?
You mean for a WebSocket service or SOAP?
Or specifically SOAP as a sub-protocol?
Oh, okay. SOAP, I would say that it would be probably a program. It wouldn't be a browser.
Yeah,
But there might be a browser on top of that program. But it would
you have a full-fledged SOAP JavaScript client at this point requires all this useful stuff. And
actually, good point. That's actually look at this slide. Good lead in. So I'm just got some top-level use cases, and the next slide shows some web service stuff. I mean, WebSocket stuff. And I think this is what you were getting at, footprint. So, and that's pretty much, you know, nobody uses SOAP on mobile devices because it's too big. You need too much infrastructure to support it. everybody uses REST. So this, I'm kind of saying that for REST, its sweet spot is public APIs. And today, that's what's going crazy on the internet, right? There's just a new startup every 5 minutes that's publishing an API so you can use their service. And they're all publishing, quote, REST APIs. And you know what I mean by quote, right? They call them REST, but you have to talk to Roy Fielding to see if they really are REST. But they're RESTful or RESTy or REST-like or anyway, so and they're good for interoperability because the thing about REST is it doesn't define any standards, right? It just uses existing internet standards. So it's great. And SOAP, you're going to use in the enterprise. And by definition, when you say enterprise, you're talking big heavy metal and big machines, and it's got all the memory you'd ever want to run SOAP for you.
From my perspective, SOAP has people schemas, so we can anytime we can validate message, and if it's not compatible with schema, you just check, but at the end of the same with the rest. This is kind of like two class of using SOAP from my perspective.
Right. That's exactly one of the reasons why enterprises love SOAP, because they really do need the strong type checking all across the board, and the end-to-end security and authentication and authorization. And SOAP does all those really well. But I don't want to argue, to promote any particular technology right now, just because I really want to stay on the WebSockets thing. But anyway, you had a question?
No, I just want to add to it. When REST is being added into the specification, so you have schema to run. It's been there for a couple of years now, right?
Which ones? What are you talking about?
REST, JAX-RS.
Well, yeah, but JAX-RS is not a schema either. JAX-RS is a framework to make it easier to write REST programs in Java.
Yeah.
But there's no, what it's sending eventually is just HTTP headers and then a body. And the body is completely up to the application, what's in the body. And so if the body wants to send XML documents and it's got a schema that it wants to validate, it can. And JAX-RS will give you some help in that, hooking that up together. But there's no spec that says you have to do that. Whereas with XML, it's SOAP, you have to, well, actually that's not completely true. Validating schema is somewhat optional too, but pretty much everybody turns it on. Yes, yes. Okay, you should talk about something slightly different, and that is, but it's the same idea, and that is, we're getting into a SOAP REST debate, but I don't want to go too much longer on that. But so that's a description, right, of the service. And there is one called Waddle for REST, but it's not standardized and it's not widely used. But it doesn't seem to have hurt its adoption at all. So getting back to I asked for it, right? I put SOAP and REST in the title. So thanks for keeping me honest. So WebSockets, here's what I'm saying are the top-level use cases, and that is browsers as universal clients that will work even in highly collaborative two-way applications. That, to me, is the sweet spot for WebSockets. You can do anything you want on those TCP streams, but this is really what they're built for. And people come up with amazing things. The trouble is, the amazing things will have to be maintained. And that turns out to, that's the trick. You know, you can write amazing things, and they're great. And if that's it, 2 minutes. Oh, wow. Okay, so let me just show you. So I was going to ask you, you know, here's what REST looks like on WebSockets. This is Jean-Francois' Swagger socket. There's a number of these out there, but all it does is take the same information that was put on HTTP and stick it inside JSON and send that across the TCP streams. And then, but by definition, this is not interoperable. So you need it on both sides. But there's some goodness about that because you can, if you've already, there's libraries that'll turn your JAX-RS application into a WebSockets application just by plugging in. Your code doesn't have to change at all. But let me show you one last thing. This is the one. Really, it can't be time to go. I got 4 minutes. Does everybody know who Roy Fielding is? He's the father of REST. He wrote this dissertation about REST. And some guy asked him, so, you know, would it be cool to do REST? 1-1, okay. And he said, okay, this is the end then. He said, it would be a different style of interaction. Generally speaking, REST is designed to avoid tying a server's connection level resources to a single client. That's what I was getting to saying, that, you know, you make a request, you get the response, you close the connection. Now you've got that connection always existing. And that connection, what's going on across on it, nobody can tell because you can't, you know, look inside. Routers can't look inside. It's indistinguishable from a denial of service attack. So Roy doesn't think too much about REST on WebSockets, but it certainly is possible. But it definitely breaks a lot of the REST constraints, which are stateless. It's not stateless. Caching, you can't cache the stuff because the content delivery networks don't know anything about what's going across. It doesn't have a uniform contract. It's not a layered system. So anyway, the purpose of this talk is to say WebSockets are cool. They have a place. They have a very defined use case. If you do anything else with them other than that defined use case, think long and hard before you do it because you'll have to maintain that code. Thank you.